Hello guys, we're going to be dealing with Benoni. This is the standard form of Benoni. The standard form of Benoni is almost the same with the standard form of linear, but then there is a little bit different in Benoni. Y to the power n is the only thing that made the standard form of Benoni to be different from the standard form of linear. But then it is easy to deal with Benoni because the only thing that we need to do first when we are dealing with such question, we need to make sure that we convert the equation from Benoni standard form to linear standard form. Right. Now, if this n is equals to 0 or this n is equals to 1, that means this equation is linear. It's not Benoni, it's linear. So that means this equation, in this equation, n should be greater than 1, right? N should be greater than 1. Now, as you know, first thing first, I need to try to explain the equation to you, or I have to explain the standard form before I can do some examples. Now, first thing first, in the method of solution, we need to substitute by v is equals to n 1 minus n, right? V is equals to y to the power 1 minus n. So this is the thing that we're going to substitute by when we're trying to convert from Benoni to linear. Then from linear, that's when we're gonna solve the equations, because now this is actually our standard form. It's Py is equals to Qy to the power n. In that, P and Q are the function or are the constant of x. They're the constant of x or functions of x. Right. After converting this Benoni to linear form, then you know that we now have to find our integrated factor, and then we solve for linear. Then after that, we have to substitute back y to the power 1 minus n into v. Then we write our final equation. In terms of y and x. Right. So I think with that being said, I need to do an example for you so that you can understand it better. Right. Example number 1. X dy over dx plus y is equals to x squared y squared, right? So first thing first, we need to put it in the standard form. Then first thing first, write the dE in Benoni standard form, right? So that we can do that by dividing throughout by x. So that means we will have dy over dx plus y over x, right? Is equals to x y squared. Why? Because we have divided throughout by x. We have divided throughout by x. Now, another thing that we need to do is to try to divide throughout by y to the power 2, y to the power 2, right? So we're going to have y to the power negative 2 dy over dx plus y now plus 1 over x y to the power negative 1, right? Is equals to x. This is now easy. So here we said this one minus this 2, we got now negative 1, then it has to be into this part of y to the power negative 1. I think you got that one. Now, what is it that we need to do further? We need to use v substitution, whereby we are saying v is equals to y to the power negative 1 to the power negative 1. So now, in this case, we need to derive this v implicitly, whereby we're going to say dv over dx is equals to dy over dx negative 2, right? So now that we have something like it's dv over dx is equals to negative y squared divided dy over dx. Now we need to take this dv, and at least, because here we have y to the power negative 2 dy over dx. Here we have negative y to the power negative 2 dy over dx. So now we need to cancel this negative so that it can fit here, so that this side can look like or can be equals to this y. Now we're going to say dv over dx is equals to y negative 2 dy over dx, right? So now it is easy for us to take this and then substitute it here, right? So it's going to be dv over dx plus 1 over x v is equals to x, because now here we are putting what? This v, because we said it is actually equals to this, right? So now we have to put this equation into a linear equation. Pardon me there. Into a linear equation. So it's going to be dv over dx minus 1 over x v is equals to negative x. I divided throughout by actually negative 1, because I wanted to make sure that it is in the linear form. I wanted to make sure that it is now in the linear form so that I can be able to do my linear formulas, so that I can be able to apply my linear formulas. Right. Now, let us find our integrated factor, which is going to be e to the power negative 1 over x dx, which is going to be e to the power ln of x, negative ln of x, which is going to be e ln 1 over x, right? Because we took this negative up front. It happened to be x to the power negative 1, and x to the power negative 1 is 1 over x. Then the final answer will be 1 over x. That is the final answer. That is our IE. Now, we need to now solve the equation, because it's IE, IF, man. It's IF integrated factor multiplied by V is equals to integral Q multiplied by integrated factor dx, which is going to be integrated factor, it's 1 over x, our Q, now our V is equals to our multiplied by our Q is negative dx. So it's going to be V is equals to x, V over x is equals to integral of negative 1 dx. Then the answer will be V over x is equals to negative x plus c. Then from there, we have to say v is equals to negative x squared plus c plus cx. Right, because now we did cross multiplication. This x went to multiply that side, then we gave this chance. Now, mind you, we said v is equals to y to the power negative 1. So we're going to put back this, our y to the power negative 1 as y to the power negative 1 is equals to negative x squared plus cx. So that can be your final answer, or you can choose to finish it up by saying y is equals to 1 over negative x squared plus xc. Right, so that's how easy Bernoulli can be. That's how easy Bernoulli can be. You just have to follow the steps and then you're gonna enjoy it. Thank you.